This is an introduction to one method of doing a proof. One way of exploring how to prove something is to first use an example and write out your example as carefully as you can, and then turn that into a proof. So we have just started looking at the overlapping segments situation. So overlapping segments are found when you have these four collinear points, A, B, C, and D, and the little segments at each end, A, B, and C, D, have the same length. So in that situation, we can create overlapping segments. The overlapping segments are AC and BD. So what happens in this situation, particularly as we look at the numbers, is that it turns out that it's always true that the length of AC is equal to the length of BD. That's not written here. I have to change this. Okay, start again. All right. In this video, we're going to look at an example of how to write a proof, a particular proof, the overlapping segments proof. In this overlapping segment situation, we have four collinear points, A, B, C, and D, and we are given an interesting fact. The distance from A to B has the same measure as the distance from C to D. The fact that each part has two tick marks tells us that. And we write it this way. AB equals CD is really read the length of AB equals the length of CD. And in proof language, we say this is given. Well, it turns out in this situation, we have these overlapping segments. We have AC and we have BD. And we're going to consider those two lengths, AC and BD, the lengths of those segments, those overlapping segments, they overlap on BC. And we're going to prove that they're always congruent. But before we set about that daunting task, we're going to look at an example. And we're going to write out that example as if we were writing a proof. So in this case, we have the four collinear points, A, B, C, and D, and AB is congruent to CD. We have one tick mark in each place. And we're given that the length of AB is 7 inches. We're also given that the length of BC is 17 inches. And you know, we can conclude that CD is 7 inches because CD and AB have to be the same. But let's write this out one thought at a time. And let's write down how we know something. So we know that BC is 17 because it's given in the diagram. And that's what we write. As you get better at proofs, you're just going to write given. But right now I'm writing a sentence, so it makes sense to you. BC is 17 because it's given in the diagram. And the length of AB is 7, again, because it's given in the diagram. Now, the other thing that's given in the diagram is more theoretical. The length of AB equals the length of CD. And that's what this says. And it's given in the diagram through the use of the single tick mark. Again, later on, you'll just say given, but here we're making clear it's given in the figure because of the tick marks. Now, because AB is equal to CD, we can make a substitution. AB is equal to 7. So we can substitute and say CD, the length of CD is 7. And we have to say that's by substitution. And you should stop and realize that's what you're doing when you say, well, these two guys have to be equal. This one is 7. So I'm going to make a substitution and know that this one is 7. You don't think about it that way, excuse me, because you do it so fast, but that's what you're doing. And this substitution should be familiar to you from algebra. Okay, so now we get to a geometric fact. This AC, which was one of those overlapping segments, the length of AC is equal to the length of its parts added together. And that's because A, B, and C are collinear. We have talked about that very briefly, but you can think about it. If they weren't collinear, AC would be like the third side of a triangle. But because they're collinear, A, B, and C, the length of AC equals the length of AB plus the length of BC. And the same thing is true with the other overlapping segment, BD. It's equal to the sum of its parts because B, C, and D are collinear. So the length of BD equals the length of BC plus the length of CD. And we had to put this down because it's not always true for any 3 points. It's true when they're on the line like this. And now all we have to do is substitute. We know the lengths of AB and BC and CD, so we plug them in. And we add and we get 24 in both cases. And so it's easy to say the length of AC equals the length of BD by substitution because they're both equal to 24. Now, that was a lot of work. Gee whiz. But it's not a proof. It's just an example written the way a proof is written. It's very helpful because it's going to help you write a proof. It's going to help us write a proof. But this is just an example because it's a situation where AB is 7 and BC is 17. It's only one case. It's not the general case for all overlapping segments. So let's do that now because it's so similar. So here I have A, B, C, and D, and they're collinear. And again, the length of AB is given as the same as the length of CD. The single tick mark in each place tells you those two segments are congruent. But now we're dealing in the world of unknown, where we can really make a proof. We're just assigning a variable to each part. We're saying the length of AB is Y because it's given in the diagram. You could have also said, let the length of AB be Y. That's this. And the length of BC in the middle here is X. And it's given in the diagram, that's why it's true. But realize X and Y could be anything. And the same thing is true as before. The length of AB is given as the same as the length of CD. They're equal because of the tick marks. So now we can say the length of CD is Y, just like AB. They're the same by substitution. And now we have the same facts about the overlapping segments. Because the points are collinear, the length of AC is the length of AB plus the length of BC. And because the BC and D are collinear, the length of BD is the length of BC plus the length of CD. So we can write the length of AC is Y plus X. But then I do something a little different. The length of AC is Y plus X because they're in that order. I just switched the order of the terms. And I can do that because addition is commutative. We can change the order of addition. And I do that to make the substitution clearer. Because when we look at BD, the length of BD is then X plus Y. These two are Y. And when I make my substitution, I want there to be exactly the same thing on the right side of the equations. So now the length of AC equals the length of BD by substitution, since they both equal X plus Y. And X plus Y could be anything. So this is a proof. This is a proof that overlapping segments are always congruent because it doesn't matter what the length is.